Welcome to Practice Questions, Week 2, Quadratic Equations. Topic. To start, I will review how to solving quadratic equations. Make it like a game, not a nightmare. Alright, first, we have to know that ax squared plus bx plus c equals 0. That is the quadratic equations standard form. So, we know A is the coefficients, the lead coefficients for x squared term. B is the coefficients for x term. And then C is the constant by itself, a number. That is our left hand side. On the right hand side is always equal 0. Alright. So, first of all, we want to check for the square root property before we think about another method to solve for the quadratic equations. And mostly when to use the square root property is after simplifying the equations, you're looking for only one square term and a number, just like x squared minus some numbers equals 0. So that how when you rewrite it, you will have something like x squared equal a number, right? Or you will have some bookie term inside parentheses square equal a number, right? And it has to be include x something in there. You can solve for x using square root property. And this is the quadratic equations. X squared minus a equals 0. And when you solve for x squared, you have is equal a. And then solve for x square root both sides. For the property, square root property, when you take the square root of x squared, you will have equal plus or minus the square root of the number represent up here, a, right? So this is our square root property. If it's more than 2 terms, it's like 3 terms, 4 terms, trinomial, you can think about the next method you think about is the zero factor theorem. So for this method, we use AC method a lot, right? And we know that if we have the product of A and B equals 0, it will be A equals 0, or B equals 0, or A equal B equals 0. This one means both of them equal 0, right? So for the AC method, we have A is the coefficient, the leading coefficients of x squared term. C is the number, right? So we know that this is the numbers, and we have to making sure that we find 2 numbers, which could be the product of that 2 numbers. This is number 1, and this is number 2. Is the product of those 2 numbers is equal A times C. And also that number, that 2 number add up to B. And then we grouping. Alright. Now from the trinomial, it means 3 terms. Like you have something with like the x squared and then plus or minus like x plus or minus a number, right? It will become like x squared plus a number 1, x plus number 2, x plus that number outside, that's c, right? So from 3 term, we break it down into 4 term and then grouping. And then using the zero factor theorems, because we factor, right? So it will be end up like that, multiply by that equals 0. Now, just set one of each equals 0 and solve for x. For the completing the square, to make it easy, we have to checking for if a equal 1 and b even number. So if a equal 1, a equal 1 and b even, you can use this formula to transform to rewrite the problem. But I think we're working on this in class, so we know how we got this formula, right? So above this one is the special case when you use that one when a equal 1. So plug a equal 1 into the second equations, you will see that you got the same thing at 1. Okay, how about if a is different from 1? When a different from 1, we use number 2. This is when a different from 1, but we have to check if b divided by a is integer. So like a number. Because we don't want to work with the fractions, we don't want to work with the decimal. So those conditions make it nice to work with. All right. Other than that, you know, we use the last method, and it can solve for all of the quadratic equations, right? But we want to making sure that we check the first one. If it not work, we do the second one. If it not work, go to the third one. And if it not work, yes, go to the last one. Why we have to follow that? Because that will save your time, and that will be avoid all the mistake you may make during calculating the um, algebra operations like subtract, minus, all the numbers, or multiplications, like all of the calculations. You may make more mistake during solving the problem. So just follow that path. Check for the square root property first, then zero factor theorems, then completing the square, and the last method to use is quadratic formula. And this is the result of solving this one, right? Now we can start a few problem to have a better understand of how to using it. Okay, so for number 1, we check for the square root property. No, right? Because it have 3 different terms. So it have 3 terms. We consider the second one, right? The zero factor theorems. Yes, that may have it, 3 terms. All right, let's see if we can factor this one. We have x squared plus 9x plus 18 equals 0. So A, B, C, in this case, A is equal 1. Where is A? These positions with the x term, right? X squared term. And then B, what is B? 9. Positive 9 right here. That is the position for B. And then C. What is C? 18. Now we use the AC method to checking if we can factor that out, right? So what is A is 1. What is C? 18. 1 times 18 is 18. So what is B? B is 9. Now what is the two number? When they multiply together equal 18. And then when they add up, like the sum of them will be 9. We can list it, right? 1 and 18, 2 and 9, 3 and 6. So, of course, this one, when we add up 1 and 18 is not 9. 2 and 9 is 11, right? Only the sum of 3 and 6. If we do here is 6 and 3, here's 6 and 3. That work, right? So now we have to rewrite the trinomial into 4 term, from 3 term to 4 term. So I rewrite it. Okay, so I have x squared plus 9x plus 18 equals 0. Now I rewrite it, x squared plus 6x plus 3x plus 18. That equals 0. So here, and the boss, right? Number 6 right here. Number 3 right here. That's how we find the color code right here. So the first number for the blue box is 6, and then the red box I use 3, right? And they combine 6x plus 3x is 9x. Now grouping. I will group the first two terms, so x squared plus 6x. The second group is 3x plus 18. So the first group, x squared plus 6x, I take x out, is the common factor between x squared and 6x. When I take x out, the leftover is x plus 6. Factor x out, we have x plus 6 inside. To making sure that is right, we just distribute it back in to see if got whatever we have upper, right, above. So x times x is x squared. X times 6 is 6x. So that's right. Now we continue. Here is the plus. Put this down. Not the multiplications, that the plus. That the additions. Okay, so now 3x and 18, the common factor is 3. The leftover inside is x plus 6 equals 0. Now we see that we have x plus 6 for the first one, we have x plus 6 for the second one. The common we take out. X plus 6 is in common. Take that factor out. We left with, now is multiplications. Now we left with x for the first term. Here x, right? the second one, the second term is 3 plus 3, right? Equals 0. Here we have the A times B equals 0 form. Zero factor theorem, right? So x plus 6 will be equal 0, or x plus 3 equals 0. For the first one, x plus 6 equals 0, I subtract 6 both sides. On the left hand side, I left with x. 6 minus 6 is 0, equal 0 minus 6 is minus 6. This is one of the answer, right? Or x plus 3 equals 0. I subtract 3 from both sides. On the left hand side, I have x. 3 minus 3 is 0. 0 minus 3 is minus 3. So x minus 3. So the solution set is minus 6, comma, minus 3. All right, the next one. For the next one, we also checking for the first one is the square root property. Number 1, square root property. It have 3 terms, so no. Number 2, zero factor. Maybe we can, right? We can factor it. It have 3 terms, so let's figure out what is A, B, and C. A is 1. B is negative 1. C is minus 56. Got it? So A in this positions, B in that positions, and C making sure have the side with it. Alright, so A is 1, C is negative 56. So the product is negative 56. And then B is negative 1. So what is the two numbers? You can think about when it have the product of that two number is negative 56 and their sum is negative 1. So I will have A and 7 will make it 56, but I want the negative, so one of them have to be negative. But which one? So we have the sum of them is negative, so the bigger number have to be negative side because you add them up, so the bigger numbers compensate with the smaller numbers to make it like negative numbers. So we have negative 8 times 7 is negative 56, and negative 8 plus 7 is equal to negative 1. Here our negative 8, 7, negative 8, 7. Now what is the next step? Rewrite. So we will have x squared minus x minus 56 equals 0. Rewrite x squared plus ax minus 7 x minus 56 equals 0. Okay, so the negative x will be rewrite at ax minus 7. I mean minus ax plus 7x, right? Because you want negative. Yeah, making sure check the work all the time. All right. Now, because we're checking it, we're making sure that's right, we go to next step, grouping. I will group the first two, so x squared minus ax plus 7x minus 56 equals 0. For the first group we have x in common, so I take x out, left with x minus 8. And then for the second group, we have 7 in common, so 7 out, we have left with x minus 8 inside, equals 0. And now we see that x minus 8 in common, right? So we take that out one more time. Take the x minus 8, we factor that, left over with x plus 7. That equals 0. Now apply the zero factor theorems. A times b equals 0. A equals 0 or b equals 0. So x minus a equals 0 or x plus 7 equals 0. So for this one, add a both sides, right? Have left x, because this one cancel out, equal 8. Or x plus 7 equals 0. So we subtract 7 both sides to isolate x on the left hand side. And that is our answer. So the solution set is minus 7, comma 8. Alright, so now we have to checking on the square root property. We have more than 2 terms. So this one, nope, right? Number 2, we have 3 terms. Yes, it may be the zero factor if we can factor that the expressions on the left hand side. So let's check it. So A is 1, B is negative 17, and C is 60. A is 1 times C is 60, B is negative 17. So what are the two numbers? When they multiply, it equals 60, and when they sum up to negative 17. We're thinking about 5 and 12, right? 5 and 12 make it 60, but then we need the sum of two numbers make it negative, so both of them should be negative, right? That makes 60. So we can take minus 12 times minus 5 minus 12 plus 5. Now we rewrite it. Okay, we have x squared minus 17x plus 60 equals 0. Rewrite one more time, x squared. Now negative 17, we'll rewrite it, negative 12 minus 5x plus 60. And that can form that, right? Okay, so I will group the x squared minus 12x for my first group. The second group, I have negative 5x inside, right? Negative 5x plus 60 equals 0. Now for the first group, I take x out because that's in common. So x minus 12, the leftover inside. For the second one, second group, I will take the negative 5 out. Left with x and minus 12. So now you have x minus 12 in common. It's left for first one with x, the second one with 5. Negative 5 equals 0. Now 0 factor theorems apply. So we have x minus 12 equals 0 or x minus 5 equals 0. So add 12 both sides. Isolate x, this one 0. This one equal 12. So x equal 12 is one of the solutions. Or add both sides by 5. Cancel that. X equal 5. Solution set is 5, 12. So this one looks similar to the question 3 we just did, but the only difference is the C. So we have A equal 1, B equal negative 17, and this case C equal negative 60. So A is 1 times C is negative 60. That makes it negative 60. B is negative 17. So what is the two number multiply produce negative 60 and sum up to negative 17? We're thinking about 20 and 3, right? So to make it negative 60, I take negative 20 times 3. And if I add negative 20 to 3, I will have negative 17. So that match. So negative 20 and 3. Alright, now we rewrite it. X squared minus 17x minus 60 equals 0. X squared minus 20x plus 3x minus 60 equals 0. So this is come from negative 17x. Now we group the first two, x squared minus 20x plus 3x minus 60 equals 0. For the first group, what in common? X left over, x minus, not square, x minus 20 plus, now 3x minus 60 in common 3. X minus 20 now x minus 20 is in common, take it out again, similar to another one. So now 0 factor theorem, x minus 20 equals 0 or x plus 3 equals 0. Add 20 both sides. to isolate x because that is 0, x equals 20, or x minus x plus 3 equals 0, minus 3 both sides, cancel that, left with x equals negative 3. Solution set is negative 3, comma 20. All right, questions number 5. 3x squared plus 13x plus 10 equals 0. First of all, we're checking for square root property is no, because it's more than 2 terms, right? So number 2, maybe. 0 factor theorem. Now let's see what is A. 3. What is B? 13. What is C? 10. A times C, 3 times 10, 30. B is 13. It's easy, right? It's just right here, 3 and 10. So 3 and 10. 3 times 10, 30. 3 plus 10, 13. All right, rewrite it. Break the 13x term into 2 pieces. So 3x squared plus 13x plus 10 equals 0. Rewrite one more time. Break it down into 3x plus 10x plus 10 equals 0. So 13x is it's going to become 3 at 10, right? Now I group the first two, group the last two, in common 3x, right? Left with x plus 1. The second one in common 10, left with x plus 1. That equals 0. So x plus 1 in common, so we do factor it out, left with 3x plus 10 equals 0. Yes, now 0 factor theorem apply. X plus 1 equals 0, or 3x plus 10 equals 0. The first one, we see that is at 1, so we want to subtract 1. We subtract 1 both sides because our target is isolate x. So x on the left-hand side, on the right-hand side, minus 1. 3x plus 10. Now subtract 10 both sides. Left with 3x equal negative 10. All right. Now x equal, divide by 3 both sides. So that we have 3 divided by 3 is 1, right? So just cancel it. We left over. The leftover is x. So isolate x on the left-hand side. On the right-hand side is negative 10 over 3. The solution set, negative 10 over 3, comma, negative 1. Alright, now this one is 3x squared equal 13x plus 10. This one is quadratic equations. We know it because the higher degree is squared right here. It's 2. So remember, we have to set this up at ax squared plus bx plus c equals 0. The 0 always on the right hand side. Everything else on the left hand side. So now we'll subtract 13x on both sides. Subtract 10 on both sides. Alright. Okay, so now on the left hand side, what we got? 3x squared minus 13x minus 10 equal. On the right hand side, 13x minus 13x, 0. 10 minus 10, 0. So first, we rewrite it to make it in the quadratic equation standard form. Alright, now we check it. The first one, can we use the square root property? No, right? More than 2 terms. Second, we're checking for the 0 factor term. Maybe. So what is the coefficients of x squared? What is A? 3. What is B? Minus 13. What is C? Minus 10. Now A times C, 3 times negative 10, negative 30, add up to negative 13. Remember last time we have like 3 times 10, right? But now that is not work. 3 times 10 is 30, not negative. If we put some negative, they not add up to negative 13 anymore. So that's not a good choice. We're thinking about something else, right? And we come up with 2 and 15. That look great, right? With the negative on the big side, on the big number, it's going to be negative 30 for the product. And for the sum, it's going to be negative 13. So that's work. So we have negative 15 here and 2 here. Now we rewrite this one. 3x squared. Now negative 13 we write out at negative 15 x at 2x minus 10 equals 0. So that negative 13 rewrite at negative 15 at 2. Alright, now next we group the first two and the last two. In common for the first group, 3x, left with x minus 5. The next group is 2 in common, so x minus 5. What in common now is an x minus 5. The left is 3x plus 2. Okay, now apply the zero factor theorem. X minus 5 equals 0, or 3x plus 2 equal 0. Add 5 both sides to isolate x. Make it 5, or minus 2 both sides. So left with 3x equal minus 2. Now divide 3 both sides. That equal 1 times x is x minus 2 over 3. The solution set is minus 2 over 3, comma 5. Alright, next. So, number 7, 6x squared minus 19x plus 8. First, checking for the square root property. No. Second, 0 factor theorems. Maybe. So what is A? 6. What is B? Minus 19. What is C? Is A. So 6 times 8, 48. Which one add up to negative 19? Three and 16, right? Or negative 3 and negative 16, that make 48. Sum them up, negative 19. So 3, negative 16 here. Rewrite it, right? 6x squared minus 19x plus a equals 0. Rewrite 6x squared, now negative 19. Rewrite at minus 3x minus 16x plus a equals 0. Now group the first two and the last two, right? So for the last two, I have to rewrite them so it's easy to see. Minus 3x. That's my first group. The second group is adding minus 16x plus a. Alright, equals 0. The first group, 3x in common. The x minus 1, not 2. 2x minus 1. 3x times 2x is 6x squared, right? Minus 1. Okay, so the second group is I take negative 8 out. So negative 8 times 2x is negative 16x. Negative 8 times negative 1 is a. Alright. 0. The common now is 2x minus 1 factor. Left over for the first one is 3x, the second one is negative 8 equals 0. Zero factor theorems. 2x minus 1 equals 0. Or 3x minus a equals 0. Add both sides by 1. That is equal 0. 2x equal 1. Now divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. So x equal 1/2. Or add both sides by 8. That's 0. 3x equal 8. Divide 3 both sides. Isolate x. A over 3. So a over 3, comma, 1/2. Now number 8. First of all, checking for square root property. Yes, a two term. So if we adding both sides by 45, what we got? We cancel out that one because it's 0. We isolate x squared equal 45. And that is this form. That saves us a lot of time, right? So now we have x equal plus or minus square root of 45. Easy. But then we have to simplify it. So x equal, we set the square root of 45, right? That equals square root of 9 times 5. That equals square root of 9 times square root of 5. That equals 3 square root of 5, right? So x equals plus or minus 3 square root of 5. Or you can write down as minus 3 square root of 5, comma, 3 square root of 5. This one means x equal 3 square root of 5 or x equal minus 3 square root of 5. So this is the benefit of checking the method, like the first method, square root property, that saves our time and effort to solve for quadratic equations. Next questions. Similar, right? Now we subtract both sides by 49. And this is number 1, square root property. Yes. Subtract 49 both sides. On the left side, left with x squared equal minus 49. Then we apply that. We take square root both sides. This one cancel. Plus or minus negative 49. And what is square root of negative number? That is square root of 49 times square root of negative 1. That's 7i. Remember, square root of -1 equal imaginary number I. So we rewrite x equal plus or minus 7i. X equals 7i or x equal -7i. Solution set minus 7i, comma 7i. Number 10. What we do first, check for the square root property. You may say no, but it's yes. Because remember I say after simplifying the equations, it means you have to combine like term to making sure that it's like the only term like you have x squared equals some numbers or some bookie thing include x inside equals some number, right? So now let's isolate that bookie square thing. We have -5. I want to isolate it, so I add 5 both sides. So on the left hand side, 5 minus 5 plus 5 is 0. On the right hand side, 15 at 520. Now you see it look like that? Yes, so now we do x minus 7. Take the square root both sides. So this one will be plus or minus, right? So that one will be plus or minus 20. Square root of 20, yes. So the first case, x minus 7 equal square root of 20. The second case, x minus 7 equal minus square root of 20. And what is the square root of 20? That's square root of 4 times square root of 5. That's 2 square root of 5. So I can rewrite one more time, right? 2 square root of 5. X minus 7 equal minus 2 square root of 5. For the first one, add 7 both sides. Isolate x on the left hand side. Right hand side 7 plus 2 square root of 5. Alright, or plus 7 both sides. That's 0. X equals 7 minus 2 square root of 5. Solution set 7 plus or minus 2 square root of 5. This one is similar to 7 plus 2 square root of 5, comma 7 minus 2 square root of 5. Okay, number 11. This one's similar, right? So square root property, yes. Subtract both sides by by 70. So 70 subtract 70 is 0 on the left hand side. And we isolate 6x plus 5 square. That equals 21 subtract 70. 21 subtract 70. The 70 is the bigger number, right? And it have the negative, so it has to be negative answer. Now take 70, subtract 21. 0, so borrow 1, so borrow 10. So 10 subtract 1 is 9. Remember 1. So 3, 7 minus 3, 49. Alright, remember when we take square root both sides, right? The x equal plus or minus square root of 8. So now taking square root, we will have 6x plus 5 equal minus square root of minus 49, or 6x plus 5 equals square root of negative 49. So this is our A, and the whole thing here is x. The whole thing equal plus or minus square root of A, right? Okay, so now the negative 49 is negative 40 square root of 49 times square root of negative 1. That equal minus 7i. Six x plus 5 equal minus 7i, or 6x plus 5 equals 7i. Okay, now we isolate x by minus 5 both sides. 6x equal minus 5 minus 7i. Divide 6 both sides. 6 divided by 6 is equal 1. So 1 times x is x equal minus 5 minus 7i over 6. That's one of the solutions. The second one, subtract 5 both sides. 6x that cancel. Minus 5 plus 7i. Divide both sides by 6. 6 divided by 6 is 1, so x equal minus 5 plus 7i over 6. Hoo-hoo, this one is more complicated, but just check for the square root property. Well, adding both sides by 101. We left 373x minus 83 square on the left hand side, because the negative 101 negative 101 adding 101 is 0. And then on the right hand side we have 183 add 101. that 2A4. And if you don't know what is the left hand side is on the left side of the equal notations, right? And then the right hand side is on the right of the equal side. All right, now we have to divide both sides by 3. That 3 divided by 3 is 1. We left with 33x. 733 x minus 83 square equal 284 divided by 3. Because it's not divisible for 3, the 2A4, how we checking on it? If we have a number, we add the digits of the sum of the all digits of the numbers together. If it can divide by 3, it will be divisible to 3. So 2 plus a plus 4 is 14. 14 could not divisible to 3. So is 2a4 cannot divisible to 3. So we keep the fractions. But now this is our big A, right? The big A right here. Here, our big A. And we have the square, so the whole thing will be x, right? Inside the parentheses will be x. So we will have 73x minus 83, that the big one, equal square root of a, square root of 2a4 over 3, or 73x minus 83 equal minus 2a4 by 3. Now we subtract 83. Now we want to add 83 both sides so that we can cancel the 83 on the left hand side. Isolate 73x equal 83 plus square root of 2a4 over 3. Now divide both sides by 73. That left with x equal that. We can use the calculator to input and have the answer. But it's good if we do it on the paper. So just write like that. It's okay. On this side, we still add 83 both sides. So left with 73x equal 83 on the right hand side minus square root of 2a4 over 3. So divide 73 both sides. X equal 83 minus square root of 284 over 3 over 73. All right, next questions. Number 13, we have x squared plus ax plus 9. All right, can we factor this one? Check for the square root property is no, 3 terms. 2, 0 factor. We have to check it, right? So a equal 1, b equal 8, c equal 9. What is the two numbers? Multiply equal 1 times 9. Add up to 8. 1 and 9. So 3 and 3, nope. 1 and 9, maybe. So 1 and 9, but then they add up to 8. 1 plus 9 is 10. How about negative 1 and negative 9? Multiply equal 9, yes, but then they add up to negative 10. So it's impossible. So we're checking number 3, the completing the square. For the completing square, I will rewrite it one more time. X squared plus, we need 2 times x times 4. 2 times x times 4 is ax, right? To make it complete square, I have to have the 4 square here. Add 9 equal 4 square. Because I add 4 square on this side, I have to add 4 square on another side, right? So we have the formula, say a square plus 2 times a times b plus b square equal a plus b all square. That's why we break down the second term, the ax term, into 2 times x times 4. So if we can look at this is a 2 times a times b, and this is our b square, right? So we will rewrite it as x plus 4 square plus 9 equal 16. Now this one will be x plus 4 square. I subtract 9 both sides to isolate the x plus 4 square term. So this one will be 16 minus 9 is 7. Alright, now this one we use square root property to solve. So x plus 4 equals 7, or x plus 4 equal minus 7. Remember, x squared equal a, x equal square root, right? Yeah, square root. Don't forget about that. We square both sides. So making sure that the square root here. All right, we continue. So subtract 4 both sides. That makes 0. That makes minus 4 plus square root of 7. On another side, we have x plus 4 equal negative square root of 7. Minus 4 both sides. That 4 minus 4 is 0. X equal minus 4 minus square root of 7. So making sure that you have all of the formula on separate paper, like your cheat sheet, so you can use it while you're doing the homework or working on a problem. So what is about this formula, right? Because a equal 1 and b is even number. So that's why we use the completing the square. And how we use it, right? That is the formula. So we just plug in, right? So you will see that x plus b is 8 over 2 square equal minus c plus b is 8 over 2 square. Oh, and c is 9. So when I plug in a, b, c into the formula, I will have something like x, a divided by 2 is 4, equal negative 9 plus 16. And this step is this step right here. Similar. Okay, number 14. We're checking for number 1 square root property. No, right? Because the square root property is only work when you have only 2 terms after simplifying the equations. Number 2, zero factor theorems. Let's say a equal 1, b equal negative 14. We can check this one is good for the completing the square. This one even, negative 14 even, good to go with it, right? C is negative 11. Now, a times c, negative 11, add up to negative 14. There's no way, right? So we know that the zero factor doesn't work. So best choice is the completing the square. And we rewrite it. X squared minus 2 x 7 2 times x times 7 is negative. Negative 2 times x times 7 is negative 14x, right? Then minus 11 equal 0. What I need for completing square here is adding 7 square. So because I add 7 square on that side, I have to add on this side well. Now this one will form x minus 7 square, all square, minus 11 equal 49. Now I want to isolate the x minus 7 square. I adding both sides by 11. Rewrite that. X minus 7 square, negative 11 add 11 is 0. Right hand side, we add 9 plus 1 is 0. 9 plus 1 is 10, right 0. Remember 1, so 60. Alright. Now this one, we use square root property. So take the square both sides. Take the square root both sides. We have x minus 7 equal square root of 60. Yes. Or x minus 7 equal negative square root of 60. Alright, the first one, we add both sides by 7. That cancel out. X equals 7 as square root of 60. Or x minus 7, we add, not a, we add 7 both sides, making sure it's the same weight is 7, but opposite side. Negative here is have to be adding here to make it 0. And do one side, do both sides. X equals 7 minus square root of 60. How we use the formula? Here is we have x plus b. B is negative 14. Divide by 2 square equal negative c. C is negative 11. And b is negative 14 over 2 square. Now negative 14 divided by 2 is negative 7. X plus negative 7 is x minus 7 square. Negative of negative 11 is positive 11. 2 negative make it positive. And then we have negative 7 square is 49. And this step is similar to that step. Okay, number 15. We check for the first method, square root property. Nope. Check for the zero factor theorems. A equal 2, B equal negative 20, C equal 84. Now check the AC method. So what two number multiply equal 2 times 84 and add up to negative 20. This one we can have what, 4 and 42, or 8 and 21, 2 and 84. Is not work, right? When you add up, is not from negative 20. So the zero factor in this case not work. Now we check a is equal to, so the simplified formula we could not use, right? But then we see that a equal to, and then we have b over a is integer. So we have negative 20 divided by 2 is negative 10. That's the integer. That's the whole number. That's the numbers. That's a nice number, not fractions, not decimal. So that's good, right? So now we divide both sides by 2. On the left hand side, we have 2 divided by 2 is 1. So we simplify it as x squared minus 10x. 20 divided by 2 is 10 plus 42. 0 divided by 2 is 0. So that's how we rewrite it, by reduce the equation by factor of 2, divide it by factor of 1/2, or divide the equation by 2. So we have x squared minus 10x plus 42 now, right? Okay, now continue. We have a now is equal 1, right? So we have x squared minus 2 times x. 10 is 5, right? Plus 42 equals 0. What we need is the 5 square. We add both sides 5 square. So we can complete the square for this one. X minus 5 square and 42 equal 25. Now subtract both sides by 42. Have x minus 5 square equal minus 42 subtract 25, 12 subtract 5, 7, remember 1, 17. Negative 17, right? So this one is square root property. X minus 5 equal plus or minus square root of negative 17. Adding 5 both sides. X equal 5 plus or minus I square root of 17. Remember, square root of negative 17 is square root of 17 times square root of negative 1. And that is I right here. So put in the front. All right, number 16. First, check the square root property. Nope. Second, zero factor. Maybe, yes, because remember we said if it have like more than 3 terms and it can factor. So by looking at this, we have 6, 7 for the coefficients right here. And 30 is what? 6 times 5. What is 35? 7 times 5. So they have 6 and 7 factor, right, in the coefficients. So I may group them so the zero factor can be work, right, by grouping. So I will rewrite it as grouping. I will group 6x cubed and 30x because it includes the 6 in common in x, right? The second group is 7x squared and 35. The first group we have 6x in common. We left x squared plus 5. The second group we have 7 in common, x squared plus 5 as well. Now the common factor is x squared plus 5. The leftover is 6x plus 7. Now zero factor apply, right? X squared plus 5 equals 0, or 6x plus 7 equals 0. Subtract 5 both sides, that cancel. Isolate x squared equal negative 5. Now this one, what we use is the square root property, right? So x equal plus or minus square root of negative 5. X equal plus or minus I square root of 5. Got it? On another side, we have 6x plus 7 equals 0. Subtract 7 both sides. So isolate 6x on the left-hand side. On the right-hand side, 0 minus 7 is negative 7. Divide both sides by 6. You have x equal minus 7 over 6. So in this case, because of the degree is 3 cubed, right? We will have 3 solutions. Mass, right? Maximum. So this is 2 solutions and this is 1, so 3. 2 imaginary complex number solutions and then 1 real solutions. So for this one, we're still checking for number 1, the square root property, and is not working, right? Because we have more than 2 terms. And also, I want all of my term on the left-hand side. And left with the right-hand side is 0. So what can I do? So I subtract both sides by negative a x squared, subtract 27x. Why I do subtract it? Because I can cancel that one on the right hand side, make it equal 0. On the left hand side, just rewrite it. Right? Now notice that 27 is 9 times 3. 24 is 8 times 3. So I will group 9x cubed with the negative 27x plus minus 8x squared plus 24. 9x cubed and negative 27x have common 9x, right? Left with x squared minus 3. I take the negative 8 out, left with x squared minus 3. The common now is x squared minus 3 times 9x minus 8 equals 0. Now we can apply the zero factor theorems. We have x squared minus 3 equals 0, or 9x minus 8 equals 0. So plus 3 both sides to isolate x on the left hand side. This one, square root property, right? So x equal plus or minus square root of 3. That's two solutions right here, right? So this one, 9x minus 8, we adding both sides by 8. Isolate the 9x. 0 plus 8 is 8. And then 9x, we divide both sides by 9. 9 divided by 9 is 1. 1 times x is x. Isolate x on the left hand side, right hand side left with 8 over 9. That one more solutions. So zero factor apply because we can do it by grouping. So we have x squared plus 5x minus 7 equals 0. First, we're checking on the square root property, and it's not working because it has more than 2 terms. And then the second one is the zero factor. Now we're checking for ABC, right? A equal 1, B equal 5, C equal minus 7. So what is the two number multiply equal negative 7 times 1, negative 7, and then add up to 5. For the negative 7, we can have the product of negative 1 and 7 or 1 and negative 7. And that two trial could not make up to 5. It's different from 5 when you add it up. So the zero factor doesn't work. Now we try completing the square. For completing the square, a equal 1 is good. But then b even? Nope, it's not even. So we don't use it. We go straight to quadratic formula, right? And what the quadratic formulas said, we have x equal minus b plus or minus square root of b squared minus 4ac over 2a. Okay, here is our ABC. Plug in, right? Right, x equal minus b is 5 plus or minus square root of b is 5 square minus 4 times a is 1 times c is negative 7 over 2 times a is 1. Now simplify it. X equal minus 5 plus or minus 5 squared is 25. This one is 25 minus 4 times 1 is negative 4 times negative 7 make us positive 28. And then 25 add 28, 1353 square root of 53 over 2. Quick and easy, right? Okay, number 19. We were checking on first square root property. Nope. Second, zero factor theorems. So A equal 2, B negative 3, C 9. What are two numbers multiply equal? 2 times 9, 18. They add up to negative 3. So we have 9 and 2, 6 and 3. But then that will be positive 18. So it has to be like 2 negative or 2 positive, right? And they could not add up to negative 3. So the zero factor doesn't work. Number 3, completing the square. A equal 2 is maybe okay, right? Maybe. And then we have B divided by A is integer. Negative 3 divided by 2. Nope, right? It's a fractions. So nope. So nope. So number 4, the last method we use is the quadratic formula. That's x equal minus b plus or minus square root of b squared minus 4ac over 2a. Alright, plug in. We'll have x equal minus, okay, minus b is minus 3, right, plus or minus negative 3 squared, minus 4 times a times c all over 2a. Now x equal negative times negative is positive, so 3, right? Negative 3 squared is 9. Negative 4 times 2 times 9 is 8 times 9 is 72 minus 72. Oh, and A is 2. Why I write A right here? is 2. All over 4 plus or minus square root of minus 72 subtract 9. 12 is 3. Remember 1 is 63. If it's 64, it's going to be nice, right? But then it's 63, that's okay then. 63 is 7 times 9. So 7 times 9 is 63. We can rewrite it, simplify it by x equal 3 plus or minus negative I, right? 63 is 63 equals 7 times 9. So take the square root of 9, square root of 7 over 4. Rewrite one more time, x equals 3 plus or minus 3i square root of 7 over 4. All right, number 20. The last questions for today. So we don't like to work with the fractions. We have to find what is the number. We can find the least common denominator, so we can simplify those fractions or convert those fractions into some number, nice number to work with. So we have the denominators. The first one is 10. Rewrite as 2 times 5. 15 rewrite as 3 times 5. And then 6 rewrite as 2 times 3. Okay, so every single factors will take ones. So 2, I have 2. Okay, here is 1, here is cross. Just take ones. 3, 5. I just take one of each factor from those denominators, right? So my LCD, the least common denominator will be 2 times 3 times 5. 2 times 3 is 6 times 5 is 30. So this is the number I'm looking for. Now I will multiply both sides by the least common denominator. All right. Multiply both sides by 30. So 30 over 10 x squared plus 30 over 15. This is multiplied by 30. Multiply by 30. X plus 30 over 6 equals 0. I distribute that 30 with each of the term inside the parenthesis. And I got that. Now I'll simplify it. What 30 divided by 10? 3. So I got 3x squared plus 30 divided by 15. 2x. 30 divided by 6, 5. That equals 0. Now it looks nice to work with, right? So first we're checking on what? The square root property. Nope. Zero factor theorems. A equal 3, B equal 2, C equal 5. A and C, 15. Add them up, have to be equal to 15 is 3 times 5. 3 and 5, but or negative 3 and negative 5, but it could not add up to 2, right? It's always be negative 8 or 8. So the third one that's not working. The third one will be the completing the square. Now A is not 1, right? So check on B. So checking on B over A can be integer. No, because 2 over 3 is fractions. So we don't working on the fractions. We don't want to work with the fractions, so it's not good to work with. So the last one, number 4, the fourth method is the quadratic formula. And remember, the formula is x equal negative b plus or minus square root of b squared minus 4ac over 2a. Now plug in. We have x equal minus b is 2 plus or minus square root of b squared is 2 squared minus 4 times a is 3 times c is 5 all over 2 times 3. 2 times a is 3. Okay. Now simplify it. Negative 2, keep it the same, plus or minus. Inside, under the square root, we have 4 right here. Minus 4 times 3 is 12. We can do 4 times 5 first, so it's like 20 times 3 is 60, so 4 minus 60 under square root, right? That will be 56, negative 56 over 2 times 3 is 6. And remember that the 56 is what? 7 times 8, and 8 is 7 times 2 times 4. This is 2 square, right? We can take it out of the square root. So that have the negative. We will go with x equal negative 2 plus or minus 2i square root of 7 times 2 is 14 over 6. Is that too fast? Okay, so I will write out the square root of negative 56 right here. That is 7 times 2 is 14 times 4 is 56. Alright, times square root of negative 1. And that is 2 square root of 14 times I. And I can write like 2i square root of 14. Alright, now simplify. We see that you have 2 right here. 2 right here. 6 is 2 times 3. So we can simplify that 2. What left is x equal minus 1 plus or minus I square root of 14 over 3. Is that too fast for this step? Alright, so I will take out the 2, right? So I will have negative 2. I will have 2 out, not negative. I will have 2L. And then left inside is -1 plus or minus I square root of 14 over 2 times 3. So cancel that one. So it's left with the answer. Thank you for participating with this week practice problem set. Hope you find the video helpful. See you next time.